started with this. So before we get into that, I'm going to give you kind of the two different formats that we're going to use for the course of this unit and the next unit for how to write a quadratic. The first one's called standard form, or the first one I'm going to write down anyway, and that is y equals ax squared plus bx plus c. A, b, and c there would just be numbers that we would have as coefficients in that lovely function there, and I hope you guys have seen that in Algebra 1. I don't know if you will have seen vertex form or not, but I'm going to write that in a second here too. Now, the vertex form looks like this, y equals a, and then in parentheses, I'm going to write x minus h squared outside of that plus k. So these are two different ways we can write the exact same function. And just to give you guys, in both formats, whatever that a value is the same. Same in both formats. Now, standard form, you cannot see the vertex. In vertex form, you can see the vertex. So the vertex from vertex form, x coordinate of the vertex would be that h value, y coordinate of the vertex is that k value, and that works just like absolute values where it's opposite copy. And then we're really not going to work too much with either one of those today. We're going to work more with graphing, just a little bit more basic version that doesn't have everything. But whenever you do this, either one of these versions, the a value cannot be equal to 0, because if it was, then you would not actually have a quadratic. Quadratic requires that you have to have an x squared as your highest power of x. So if a was 0, we would not have an x squared. All right, now what we're going to start out with, this is really the only algebra we're going to do today. We are going to put both of these equations that we've got in example 1 into standard form. Okay, all we're going to need to do that is basically get rid of the parentheses in both of these formats. And then I'm going to have you identify what we call the quadratic term, the linear term, and the constant term. So if I was trying to get rid of these parentheses in this first example, I've got y equals x plus 4 times x minus 3. What would you do to multiply that out to get rid of the parentheses? And we did a little bit of this in our last unit. Yeah, go ahead. Tell me what you do for this problem. Yeah. So what would you write? Yeah, we're going to do that in a sec. Yeah, too. What do I get if I do x times the negative 3a? Yeah, there you go. All right, and then we're just going to multiply these guys both by 4. So then what would I write down? There you go. Perfect. Okay. Now, can I simplify what we just wrote down in any way? So what would you write down? There you go. These guys go together, right? X squared negative 3 plus 4 would just give you 1x and then minus 12. Okay, this would be the standard form. That's very similar to what I wrote down as the definition. Now, I'm not asking you to do this, but in that case, the a value would be 1, the b value would also be 1, and the c value from that form right directly above that would be the negative 12. What we're going to ask you guys to do on this first question is identify the quadratic term, the linear term, and the constant term. Okay, so I'm just going to abbreviate this. The quadratic term is just whatever the term is with the x squared. So in this particular question, it is just x squared. There's nothing in front of it. If it had a coefficient, we would write that too. The linear term is your term with your plain x, and actually in this question, that is just x. And then the constant term, constant is just a fancy math word for plain number. So the plain number in that equation after we multiplied it out is negative 12. So basically it's just each term is defined. Now, depending on the question you're working with, you might not have a linear term or you might not have a constant term if you're dealing with the quadratic, but you should always have a quadratic term. So it's possible you might be missing one of those. You're going to see that in a couple examples today. Okay, Now I'm going to try one more. This one is written in the vertex form, really similar to right above here. And I'm not going to ask you to identify the vertex or anything. We'll get into that later in the unit. But I do want to put this in standard form. So I got to multiply this out. If I multiply the 3 times the x plus 5 squared and then the minus 7, anybody know what you should do first there, like in your order of operations? Should I like distribute the 3? Should I do the exponent? Like what should I do? Okay, good. I was about to have a heart attack. Okay, now the other thing, just remember for me real quick, don't distribute an exponent. Like if I have x plus 5 squared, right? If I just write x squared plus 25, I'm missing out on the middle term. So be real careful with that. I want to square this first. If you square something, you're multiplying it by itself. So just write it out twice. And what I'm going to do is just do like a FOIL like we just did on the last question with that. But don't just distribute the exponent because you'll completely miss out on the middle term. Anytime you've got something squared or to a power that's got adding and subtracting, make sure you write it out twice so you can multiply it by itself. Okay, now here's what I would recommend to you here. Don't distribute the 3 in there. What I would tell you to do, let's just focus on that exponent. Just FOIL that together. If you like to draw a box, draw yourself a box. Go ahead and do that. Just leave the 3 on the outside for a second, all right? So if I do a little FOIL here, right? X times x, give me x squared. X times 5, give me a 5x. And I'm going to turn around and get that again. I'm multiplying this by itself. So I get another 5 times x. So I get another 5x. And I get 5 times 5, that's 25. Now, I'm going to keep parentheses around that because I only want to distribute the 3 to that set of parentheses. That negative 7 was outside of that, so I'm going to leave that outside there too. All right, and before I distribute, I'm just going to combine like terms real quick here. 5x and 5x would put together as 10x, and then I'd have plus 25. Again, don't distribute the 3 to that minus 7 because that's not how it's set up in the equation. To get this done then I'm going to go ahead and distribute the 3, and I'm going to throw my pen clear across the room doing it apparently. So I got 3x squared plus 30x, just multiplying everything by 3, plus 75, and then I still have that minus 7, and as the very last step, I can combine that with that negative 7 with the 75. So in standard form, this would be 3x squared plus 30x, and then 75 minus 7 would give you 68. Now, if we're talking about our A, B, and C values from the standard form, A would be 3, B would be 30, and C would be 68. If we have to identify, which that's what the question asks us, the quadratic, the linear, and the constant term. Okay, quadratic term is just the term with the x squared, including the coefficient. So this would be 3x squared, that whole term. The linear term is your term with your plane x. So in this question, that's the 30x. So take the coefficient with it. And the constant term here is any plane number. The plane number I got on that question is 68. Is anybody having a question? Okay. The rest of what we're going to do today, we're going to really dive into graphing parabolas and looking at parabolas and their different parts. So parabola, literally all that is the fancy name for the graph of a quadratic. And a quadratic just means my highest power of x is going to be that x is going to be squared. So quadratic, and it's going to make a U shape. Now, what we call the axis of symmetry, I'm going to come over here and I'm going to draw it on this graph that I've got to the side here. And forgive, this should have arrows on the end of the, it does continue up forever, but I'm going to come over here and I'm going to draw in the axis of symmetry. So the axis of symmetry literally is a line that I could draw right down the middle of a parabola, and it would split it exactly in half into 2 equal pieces. It's always a vertical line, and it would be if I were to literally take the graph and fold it in half on that line, the 2 sides would match up. So axis of symmetry, it's a vertical line, and I'm going to just say it splits parabola in half through the middle. It's always going to be a vertical line because the parabola is always either going to turn up like that graph does, or we might have one that goes upside down, but the axis of symmetry will always be a vertical line that goes through the middle. Now, I'm just going to write this real quick. Axis of symmetry, it's always a vertical line, so I call it vertexal to help me remember it, but it's just x equals a number, all right? And in the case of a parabola, it's going to be x equals whatever the x coordinate of the vertex is, because it has to go through the vertex. So it will just be, for the equation, it'll just be x equals a number, and just in general, it'll be the x coordinate of the vertex. We're going to do a specific equation for this example here in a second that's on the paper. And then the last little definition I got there is for what the vertex is. Does anybody know what the vertex of a parabola is, just in general? Like what the vertex is? It's similar to vertex for an absolute value. What's a vertex? Oh. Yeah. It's the lowest point. Okay, so on this little example here, it's the lowest point. I'm going to write this on here, though, because if the graph turns another way, it could be a different description. Okay, so it's either the lowest or highest. I'm going to draw a little picture, and I'm going to spell that correctly. It's either the lowest or the highest point. On the little example I have right here to the side, it would be the lowest point, because it would turn and be at the very bottom of the graph. If your parabola, though, flips the other direction, it could be the highest point on the graph. So it's one or the other, but it is literally either the very bottom or the very top of the graph, depending on which way it turns. Can anybody tell me what that point would be for the picture I've got on the notes here? Like, what is the vertex of this graph? Right, just the lowest point. It's over 3 up 2. There you go. Now, your axis of symmetry, we've already got it drawn on the paper probably, has to be an equation. Axis of symmetry is an equation. It's a vertexal line. It's just going to be x equals some number. What number are all the x values on for this example? What number would I put? X equals what number? 3. Perfect. Done. The only other thing I'm going to have you do with this question, just real quick, do you see how there's 2 tiny little points? One says P and one says Q. This is a little bit of a throwback from geometry. So right underneath here, it says, the way you would read this, it says P prime and Q prime. They're not on the graph. We're going to draw them on the graph here in a second, are the points that correspond to P and Q on this graph over here. Now, if you guys, I don't know if you got to this unit in geometry or not, but prime, it's just a reflection. So this would be, the way I would read this, P prime, and all it is, it's a reflection of that same point of P over your, I'm going to abbreviate axis of symmetry, I'm going to write AOS. So if you have a prime, you're going to have a point given to you somewhere on the graph. All you got to do to get its reflection is push it across the axis of symmetry. So if I look, P on the actual graph is given to us right here. So it looks like this is the point 1,6. Okay, so to get P prime, I'm just going to reflect it over the axis of symmetry. So this guy's 2 spots away here, so just 2 spots away on the other side, and it should be right on the parabola. So its reflection, that would be P prime. So the question here is just asking you what are the coordinates of that point. So after I reflect P, that's reflection over the axis of symmetry is just the point 5, 6. That's all you have to do. I also have another point Q there, and same thing. It says what's Q prime? Q prime just means you're going to reflect that point over the axis of symmetry. So it's just 3 spots away, so just come 3 spots away on the other side. And that reflection point that we would call Q prime, and they just want the coordinates of the point to fill in that little blank there. So this is going to be, what is that, 0, 11. Is anybody having a question? So if you see a prime, it's just asking you to reflect it over the axis of symmetry, and it should be on the parabola if you're looking at a graph. Is anybody having a question? Okay, now I'm going to have you guys graph what we call the parent function, so the most basic version of a quadratic. I'm going to have us graph this by hand, and then I'm going to show you a little cheat to help you graph all the other parabolas that we're going to do in this unit so you don't have to use a table. Okay, so most basic version of a quadratic, not shifted, not stretched, not shrunk, nothing, just y equals x squared. That's all it is. Now, we're going to go through and just fill in the table here real quick. So I'm going to plug in these x values for x. So on that first one, if I square negative 4, what do I get if I square negative 4? It should be positive. Okay, all these guys should be positive, right? So this is 16. 3's, or negative 3 squared, negative 3 times negative 3, that should be 9. These are all perfect squares. Negative 2 squared, 4. Negative 1 squared, 1. Now, 0 squared just stays 0. And then the rest of these will be exact copies of what you did. You get the same thing if you square 1 as you do when you square negative 1. You get the same thing when you square 2 and negative 2. They give you the same number. So it's going to be like 1, 4, 9, and 16. And then what I'm going to ask you guys to do, these should all fit. Just come over to the graph here, and we're going to actually plot these points. So what point on there is the vertex? Right, the 0, 0. Do you guys see how the like if you look at the table, right? This is 1, 4, 9, 16. This is 1, 4, 9, 16, same numbers. That 0, 0 is right in the middle between where those patterns start and stop to repeat. So that's got to be the vertex. So vertex here, it's actually just going to be right at the origin. And then all we're going to do, just plot these points. You got 1, 1, and negative 1, 1. So there should be a mirror image on either side. This will create the U shape. And I've got 2, 4, and I got negative 2, 4. So again, they should be right, they're a reflection of each other. The axis of symmetry here, we're going to write that down in a second, but it should just be the y-axis. You got 3, 9. You also have negative 3, 9. And then I have 4, 16, and then I'd also have negative 4, 16. Now I know this graph is kind of big, so do not make it have a point like an absolute value. Just try to do your best. These make a U shape. So just as you kind of try and connect these up, just do your best to make it curved here at the bottom. If we had more points on here, we could make this maybe more accurate. But this is going to be good to describe what it looks like on the graph there. Okay, axis of symmetry. I'm just going to draw it on the graph here real quick. Is for this graph, it's not shifted in any way, so it's just actually going to be the y-axis. And that'll be the axis of symmetry for all the questions that we're going to look at today. We'll move them around in our next lesson. But my axis of symmetry there, it's just going to be, and I know this is weird because it's the y-axis, but it's actually the equation x equals 0. So it's a vertexal line that is actually the equation of the y-axis, is x equals 0. The y values change as you go up and down, but the x's are all 0. Can anybody tell me what the domain would be, like how I'm moving left and right from that graph? I'm just going to have us write an interval. Like, so if I start at the left and go to the right, what would you write down for your domain? And this will actually be the same for all the parabolas that we're going to do. What do you think? On this graph. Okay, but pretend we put arrows on it. It's going to continue. What would you put? Yeah. Okay, now, it goes up really fast, but it does go to the left forever, and it does go to the right forever. So it would eventually widen out and cover the entire x-axis. So negative infinity to infinity. That'll be the domain for every single parabola we graph. Okay, now the range, if you're going to write your interval, the range, you want to come from the bottom of the graph to the top. This will not be negative infinity to infinity. What is the first y value that I touch on this graph? 0. Okay, now that's our actual vertex, and so we have an actual point there. So I'm going to use a bracket. The lowest possible y value is 0, and then it goes up forever to positive infinity. Now, don't flip over yet, because I'm going to show you this thing before we move so we can have a cheat for how to graph these. Is anybody having a question at the moment, though? Okay, I'm going to show you a pattern that I'm going to draw on this graph. See if you can notice the pattern. And this is what we can use to help us graph these a little bit faster than making a table like that. So from the vertex, to get to the next point, I'm just going to do this on one side, but you could do this on either side. To go from the vertex to get to the next point I put on the graph there, I went over 1 and then I went up 1. Okay? To get to the next point, I went over just 1 again and I went up 3. From that point, I went over 1, again, just over 1 every time, and then I went up 5. Okay, now without counting it, if I go between the next 2 points, I'm going to go over 1. How far am I going to go up? 7. Can you guys see the pattern? Okay, and that's just the difference when you have, because we're working with perfect squares here. If we did another point on the graph, we'd have the point 5, 25. It'd go over 1, up 9. The one after that, I know I don't have a graph big, but it would go over 1, up 11. So you can use that pattern. It's just over 1 and then up odd numbers. So over 1, up 1, over 1, up 3, over 1, up 5. It's not a slope like a line, but you can use that pattern to help you graph that curve on any parabola. So we're going to use that on the back instead of making these tables to make it go a little bit faster. But that pattern goes for every single quadratic. Is anybody having a question? Okay. So all I'm going to do is I'm going to just write this at the top here. So it says quadratic graphing pattern. Now this is if A is equal to 1. So as an example, that just means you start out with an x squared. So I just call this just 1, 3, 5. We could keep going, but usually the windows on the graphs that we get provided to us on these worksheets and stuff don't really go up higher than that, but it would go like 7, 9, 11, whatever. To actually put it on the graph though, from the vertex, you're going to go over 1, up 1. Then you would go over 1, up 3 from that set of points, and then over 1, up 5. And you could keep going on that pattern. It's always going to be over 1, and then the next one would be over 1, up 7. But usually, like I said, the graph isn't big enough to get that many points on there. All right, so you got to find the vertex, and then you can use the pattern. That is the key to doing these questions. So if I give you this graph here, I have just x squared minus 5. So the difference between that and the parent function, we just did x squared, is I've added in here a minus 5. So if I add in that minus 5, what is that going to do to the graph we just did? Well, how would the minus 5, if I just do, instead of just an x squared, if I do x squared minus 5, how would that affect the graph? Anybody know what the vertex of that would be? Okay, I'm just adding a minus 5. Is that going to go up, down, left, right? What's it going to do? Down. Okay, I'm going to have a heart attack here. All right, look, this is minus. It's outside the operation, right? I'm not putting like x in parentheses with something and squaring it. All this is going to do right here, this minus 5, it's going to take what we just graphed and it's going to shift it down 5 spots. So your vertex here is going to be 0, 5. Every single graph you're going to do today, the x-coordinate of the vertex should be 0. There's nothing going to shift left or right. I'm only going to shift maybe up or down. Okay, so instead of 0, 0, we're just going to put our vertex on 0. Oh, I'm sorry. 0, negative 5. That's what I meant to say. 0, negative 5. My fault. So we're down 5. Okay, so here's 0, negative 5. Okay, now my a value is just a plain x squared. My a value is positive 1. And so I'm going to use this pattern, this 1, 3, 5. Literally, all you have to do, just from that vertex, once you get a graph, on either side, just go over 1, up 1. Once you got those 2 points, starting from there, just go over 1, up 3. And then you're just from there, go over 1, up 5. I'm just doing this on either side. So just start at the vertex, Just over 1 on either side, up 1, over 1 on either side, up 3, over 1, up 5. I don't think I could fit any more on here, but if we did, the next one would be over 1, up 7 on either side. And that's going to give you a perfect example of what this should look like. And just as you draw it, if you go back to play connect the dots here, just do your best to make it a curve so it looks like a U shape. I'm going to put little arrows on the end. Now, for this graph, let me just write the domain real quick and the range. So the domain for every single one of these, negative infinity to infinity, it's going to go left and right forever. What would you guys write for the range for this graph? Like, what is, if I go from the bottom to the top, what's the first y value I touch there? Negative 5. So it's just the y coordinate of the vertex. And then this one goes up forever. So negative 5 to infinity would be my range. All right, now, switch over. This one's a little bit different. So this one next to it, I have negative x squared plus 7. What is the little negative going to do to the graph? Make it negative. Exactly. Look, this literally just flips it over. Okay, now, does anybody know what the vertex of this one would be? 0, 7. Yeah, 0, 7. Yes. So the negative is going to flip the graph over, but we're not shifting it left or right, so that x coordinate of the vertex is going to stay 0. So just do your best, put a little point on 0, 7. Okay, now the only thing that's different here, my little pattern, right, is 1, 3, 5. But my a value here is negative 1. All right, the only thing that's different, I'm literally just going to think about distributing that a value to my little 1, 3, 5 pattern. The pattern for this graph would be negative 1, negative 3, negative 5. What you're going to do differently is I'm just going to go over 1, but go down 1. And then over 1, down 3, over 1, down 5 from that vertex on either side. So just on either side, just go over 1 from the vertex and down 1. Once you get those 2 points, just from either one of them, go over 1 and then count down 3. It's every time it's over 1. And then I'm going to do over 1, down 5. Just use that pattern. It's just going to be negative because of the negative in front of the x squared is going to cause it to go down. It should be kind of the same width as the other graphs that we've just done. And I do want to write the domain and range for this one too, just real quick. No matter what, domain for any of these, it's going to go left and right forever, even though it's pointed down. One end goes to the left forever, one end goes to the right forever. The range for this one, though, is different than the two we've looked at so far. You want to take and write your interval for the range from the bottom to the top. So this points down forever, right? What should I start my range with for the interval? Negative infinity. And if I'm tracing this graph, I would always be touching part of it, and the vertex is actually the last point on the graph that you would touch. What would you tell me the range would stop at? 7. And again, it's just the y coordinate of the vertex, and we're just going to use a bracket because we have an actual point there. Is anybody having a question? Okay, I kind of mentioned this in the question we literally just did, but your a value, if it's not 1, the graphing pattern, you can still use the 1, 3, 5. What you want to do is just multiply that pattern by whatever is in front of your x squared. So if you've got a different number, we're going to do this in the last example down here. We're going to have the graphs be a little bit more narrow or a little bit wider, but literally all you have to do, find the vertex, and then to do the pattern, if it's something in front of the x squared, we'll just multiply that by the pattern, and it works the same way. All right, so if I just have, see if you could tell me the vertex here. So all I have a number in front of the x squared. I don't have anything added or subtracted or anything like that. I have y equals 3x squared. Anybody know what the vertex would be? I have 3x squared. What would the very middle be? Yeah, you're not shifting left or right. Okay, the 3 in front of that is going to be, if you guys remember this from our absolute values, it's actually going to be a vertical stretch. This is going to be more narrow. And I don't know how much of this we're going to be able to get on the graph, but we'll do our best. So 0, 0 is going to be the vertex. Okay, that 3 is going to affect your pattern. All right, so for this graph, I'm just going to take the 1, 3, 5 and just multiply each piece of that by 3. So the pattern for this graph, because we have 3x squared, is going to be 3, 9, 15. Which I think we're only going to be able to get a couple of these on the graph. I think it's not tall enough to do the 15. But in the questions that you guys are going to do for test quizzes, homework, whatever, it's just going to say you have to graph at least 5 points. So we should be able to do that. So this is the pattern I'm going to use. So here's the difference. Every time you're going to go over 1, on this one, I'm going to go, instead of over 1, up 1, I'm going to go over 1, up 3. It'll be more narrow. After that, I would go over 1, up 9. And I don't think we're going to get the 15 on the graph. So just these 2 sets will be okay. So from the points you just did, go over 1 and then count up 9. You should be at the point 212 and negative 212 to do that. And then the graph just isn't tall enough for me to go up 15 spots. So this is plenty. I got 5 points on here. And just do your best, make it a curve at the bottom so it's a U shape. And that's all you have to do. Does anybody have a question? Okay, I'm going to give you a different one that's got a number in front of the x squared. So this one says y equals 2x squared minus 7. Can anybody tell me what the vertex of that would be? Yes, ma'am. Okay, nothing moving left or right. This is just 0, negative 7. The 2 is going to stretch the graph. All right, so if you guys come over, plot that 0, negative 7. I do have a number in front of my x squared. So that's going to affect the pattern for this graph. So I'm just going to take 2 and multiply it by that 135. So the pattern for this graph that we want to use to get our points would be 2, 6, and 10. So it works the same way. So we're just going to go over 1, but we'll go up 2. Then we'll go over 1, up 6. And I don't think we'll be able to fit it, but we could, if we could, it'd be over 1, up 10. So just from this graph, once you get the vertex, just over 1, it's always over 1, and then up 2 on either side of that vertex. And then I'm going to go over 1, and I'm going to go up, let's see, 6. Should put you at 2, 1, and negative 2, 1. And then the graph isn't tall enough for me to go over 1, up 10. But this is 5 points, so we're good. Just a little curve here. Is anybody having a question? Now, the last one, I'm not going to lie to you, this is the trickiest, okay? I have a fraction, which is going to actually kind of compress the graph. It's a shrink. It's going to make the U shape a little bit wider. So my A value on this last one is a half. Can anybody tell me, before I try and do the pattern with you guys, what would the vertex be if I have 1/2 x squared minus 4? What would the vertex be? The very middle. Because I got to have a starting point before I can use my pattern. Perfect. Okay. Nothing with the x, nothing in the middle. It's just 0, negative 4. That's going to be my vertex. Okay, now, this is my recommendation to you. Remember in the other ones I told you take the A value and multiply it by the pattern. That's what I'm going to do here. But I'm going to write the A value as a decimal instead of a fraction, because I think people get confused and they start going like over 2 up 1 or something like that, and they use the fraction like they would use a slope. So just do this for me. Just do this as a decimal because I don't want you to do that. So I'm going to do the 135. That 1/2 is going to affect that pattern though. It's going to widen the graph out. I'm going to write these as decimal places. The pattern for this graph, 1/2 times 1 would be a 1/2 or 0.5. 0.5 times 3 is 1.5. And 0.5 times 5 is 2.5. So that's going to be the pattern for this graph. So what I want you to do You're going to go over 1 every time, and you're just going to kind of estimate up a half. Just kind of go right in the middle of the grid mark. So from your vertex, I'm just going to go over 1 and just, at the best I can, halfway in between the grid marks. Just a half, just estimate. It doesn't have to be perfect. Now, from there, I'm going to go over 1 and up 1.5. That will actually put you on a nice point. So I'm on the halfway part. I'm going to go over 1, up 1.5, should put you right on 2, -2, and -2, -2. And then I'm going to do that just one more time. Over 1, up 2.5. And again, now I'm right on a corner. So over 1, up 1, 2.5. So it'd be at the point like 3.5 and -3.5. And just kind of estimate where the half would be. And you guys can see this is a little bit wider than the other graphs that we just did. So if you end up with a fraction as your A value, I would just really encourage you, write it as a decimal. It's always over 1, and then if you have to estimate, it doesn't have to be perfect. Just a half would be like right in the middle of the grid mark. Is anybody having a question?